Okay, welcome everybody to the first Soda Labs webinar series. You've all received the invitations. Normally we run the webinar every Tuesday on a bi-weekly basis. We are roughly now booked until October. In general, the series is about bringing together people who work with interesting data or interesting new methods around answering social science questions. Of course, I mean, given that Soda Labs has a large group of economists, and within the economists group, a relatively large group of political economists right now, number of speakers will be from that area, as well as political science in the coming weeks. Today, I'm very excited to have Dominic Rohner, as well as his co-authors Massimo and Quentin here to present their paper. Just in terms of house rules, if your internet connection allows, maybe if you can switch on the camera, because that's often nicer for the presenter if they see some faces. If not, that's fine. And otherwise put on mute. And Dominic, as I said, brought his two co-authors with him. And what we agreed on is that if there are some more general, broader questions on the topic, just raise your hand and Dominic will answer them. And in addition, if there are more detailed questions or suggestions, you can put them in the chat, and then there are Massimo and Quentin there who can answer the questions for you. And the seminar is basically 1 hour as usual, and that's basically about it. I will hand over the floor and the microphone to Dominic. Today's talk will be about conflict in the pipeline, natural gas networks, and interstate disputes. And Dominic, the floor is yours.
Okay, thanks a lot for inviting me. It's a big pleasure to talk with you. It's the first time I present this paper, so we'll still be a bit rough, very much work in progress. We're still finalizing the draft, so it's the perfect moment to get your feedback, to incorporate it as well. So okay, let's get started right away. Here we go. So you should see my slides, right? Okay, so paper is called Conflict in the Pipeline, Natural Gas Networks and Interstate Disputes. It's joint work with Quentin and Gallea, who just finished a PhD in Lausanne and now found a nice position in Zurich, and Massimo Morelli, who is a professor in Bocconi University, and it's a great team. It's great to work with Quentin and with Massimo. So what's the motivation of our paper? Our motivation is basically, as you know, natural resources and conflict are a big topic. So often they're argued to be a major driver of conflict. People think of oil, gold, diamonds, etc. And there's this big literature on the natural resource curves. So one of the kind of gaps in this literature is that natural gas has received relatively little attention, and that's very surprising, because basically it's almost as important as oil. So if you think of the major, so fossil fuels are really important. They make up more than 80% of energy in the world. When I first saw this statistic, I was shocked, because like in Switzerland, you know, we have all these nice rivers, and we have a lot of hydro energy that creates electricity. So I didn't expect oil, coal, and natural gas to be so big. But basically, natural gas is a quarter of our worldwide energy. So it's a huge chunk, huge geopolitical importance, and it has not been that much studied, actually, the role of natural gas. And conceptually, people have thought of natural gas as something a bit the same as oil, but that's very wrong, because basically natural gas has very different features from oil. So natural gas should be separated from oil because network effects are really important. Actually, what's going on is that most oil is shipped by big tankers around the world, while the biggest part of natural gas is shipped through pipelines. You can liquidify natural gas, and you can and send it through tankers, but it's really expensive. And you only do that for places where you don't have any other means of doing it. While if you're Poland and you want to import Russian gas, then it's much cheaper to do it through a pipeline than through liquidifying and send it around the world with some ship. And so, which means that actually this fact that the pipelines are so much cheaper is that now location starts to matter and networks start to matter. So if you're a country that is really a very central node in the middle of some important pipeline network, then you have a lot of position rents. You have a lot of monopoly power for this gas deal, and so that's what we're after here, and that's kind of and that's very new. So that's not something that has generally been looked at in the literature. Let me just here we go. Yeah. And so really for gas, while for oil it matters how much oil you have, how many reserves, etc. For gas, the position in the network may actually turn out to be even more important than the endowment of natural gas. And so that's why it's very crucial to study natural gas as a separate item, because it's a very different animal from other natural resources, and because it's a crucial chunk of energy, 1/4 of world energy, and it has been completely understudied. So that's why we study this. Now, what do we do exactly? So we built a new data set of the network of natural gas pipelines for Europe, Africa, and Asia. Because, I mean, these 3 continents, they are connected geographically in a way that we can kind of have a common network going through these continents. So I mean, we could include Australia, but then Australia would kind of be a separate network because it's so far, right? It's not connected through a pipeline. So basically, yeah, we study these 3 continents. We start with setting up a formal game theoretic model of gas and oil trade networks in conflict, thinking about this in terms of a model. And then we take our predictions of the model to the data, and we in terms of identification strategy, what we do is we exploit the interaction of the pre-sample network structure with gas price shocks. So we look at, well, what are the places where, in principle, we should expect danger and the potential for hostility, and we interact that with gas price shocks, which then mean that in some periods these dangerous fault lines of the network are more salient due to the price shocks. And so we do that to see whether we can explain interstate disputes, military interstate disputes. And then based on that, we perform some counterfactual simulations. So what do we find? Well, first we find that network centrality really matters. It is a key driver of conflict. So it turns out that the attractiveness of controlling some key nodes in these high price periods is a powerful driver of these interstate disputes. And so to just illustrate what kind of context we have in mind. So think of Azerbaijan and Armenia with the Ganja Gap, a region a region where you have 3 pipelines going through, and where basically if you want to connect Russian oil to some other important importer countries, it has to go through there. So basically that would be typically the kind of hotspot where Azerbaijan and Armenia, the one of them who kind of controls the area, would have a lot of rents from that. And these situations of the high potential of gaining from conquering some other country or winning some war against another country, this is kind of magnified by high price situations. So that's the kind of animal we're looking at. So basically, to be more precise, we have this theoretical prediction in the model, and then we find this new evidence on that, and what we find quantitatively is that one standard deviation increase in the gas price would increase in these high risk diets that are very like central nodes, would increase the risk of conflict by roughly a third of the baseline conflict risk. So it's in the order of magnitude of around 2-3 percentage points of conflict risk for a diet year, and which is like a third of our baseline conflict risk of our sample. So fairly big effects. Then we link our results with existing work on oil. In particular, together with Massimo and with Francesco Caselli, we have a QJE paper where we look at oil asymmetry, where we basically find that if in a country pair only one of them has oil and kind of close to the international border, then the other country in the country pair would have high-powered incentives to invade the neighboring country to grab the oil close to the border, and we find that this oil asymmetry plays a big role. And so and that's like paper 5 years ago. And now in this current paper, what we do is we revisit this old finding that we had with Massimo and Francesco, and we look at, well, does this still hold? And is what we are doing in this network paper today, is that kind of just telling the old story a bit differently? Are we just picking up like the old asymmetry effect? And it turns out no. So what we find is that our current network effect of the gas pipeline network, they go through, they are not affected when we control for oil asymmetry, but at the same time, our old results on oil asymmetry also continue to hold. So basically, what we find is that the two are complements. They're not substitutes, but we have both channels present. For oil, what matters is what matters is basically the oil endowments and the asymmetry in oil endowments, while for gas, what matters is the network position. And that makes perfect sense, because oil you ship through tankers, and the network is not important because you ship it, you know, whether you ship the Texan oil to France or to Germany doesn't matter much, because you ship it through tankers anyway. While for gas, really the network matters. And so that's our second finding that we exploit in this paper as well. And then at the end, we look at simulation. So the third finding is we look, for example, the network of pipelines has densified over the years, and we find that this typically increases the conflict risk, this denser network, because there are more friction points. And we then also have a few words to say about particular pipeline projects. You know that there are currently some pipelines planned, and we can say, well, if this pipeline is built, then typically we would expect a higher risk of conflict between these two countries, which now become kind of central nodes, whereas before they were not central. And so we will say a bit of that, and then like many other papers, we also say a bit something about COVID, COVID-19 has reduced gas prices, and we can quantify what the effect of this is in terms of reducing interstate disputes. Okay, so say a few words. I'll say a few words on the literature. I'll be a bit brief because basically, yeah, in the interest of time. So the literature on natural resources and conflict has focused quite a lot on civil wars. So there are papers on primary commodities, oil, minerals, diamond, etc. Also not that much on gas, actually. But yeah, so this literature is mostly on civil wars. There are very few papers in economics on natural resources and interstate wars. There are a few in political science, but their focus is somewhat different. So one paper, one exception is the paper with Gallea and Morelli, 2015, that I mentioned before on oil asymmetry. But there are not that many papers actually on natural resources and interstate wars. There are a few papers on trade networks and other networks in general linked to interstate disputes. Martin et al., Restart 2008, or general paper on networks and civil conflict. We have one as well with König and Silibotti recently. Yeah, so basically, so this is like a bit of an overview of the literature. What do we add to this literature? What's new here? Well, the first thing that's new is that we have a novel data set on natural gas pipelines. The second thing that's new is that we focus really in particular on the role of natural gas. And we argue that it's very different from oil because, as I was saying before, natural gas goes through pipelines while oil typically goes more often through ships. And so that's why the pipelines, the network structure now really matters. And the third new thing is really not just the natural gas as such, but it allows us also to say more about network effects in general about for the resource curves. So these are kind of the three main new points. In terms of data sources, our sample, one observation in our sample is a country pair in a given year. So it's a panel data set at the country pair year level. So one observation would be, for example, Russia, Ukraine in the year 2000. Okay, that would be one observation I would like. And our data set contains the all country adjacent pairs in Europe, Africa, and Asia. So we only look at neighboring countries because these gas disputes are typically between neighboring countries. Think of Armenia and Azerbaijan. You don't usually have a gas dispute between, say, Switzerland and Ukraine, right? So typically it's kind of adjacent countries. And also, in general, the literature on interstate wars shows that being a neighboring country increases many-fold the risk of interstate wars. So we focus on that. And the reason we focus on Europe, Africa, and Asia is that these, geographically speaking, these continents are connected with each other, and there's no ocean between them. So we can kind of think of one general network. For the natural gas network, we rely on own data that we collected, and we have data from 1960 to 2018. We used Energy World Atlas, Energy News websites, natural gas companies, etc., like a whole battery of different sources, and we know where the pipelines go through, and we know in what is the first year when the pipeline was functional. So in terms of conflict data, we use standard data from correlates of war, the military interstate dispute data set. It has 5 levels of intensity. One is nothing, threat to use force 2, display of force 3, use of force 4, and 5, war, a full-blown war. 5 is pretty rare. That would be something like the Falklands War, for example, or the Gulf War. Use of force is also quite heavy. So that would be like if there is some dispute on some plane being shut down by some other country, for example. And so yeah. So what we do is that in line with the existing literature, we have two variants. We run some regressions where we code as militarized disputes conflicts of levels 3, 4, and 5, or alternatively an alternative measure that is more narrow, where we focus on level 4 and 5, and we find the same results basically for the two measures. Okay, so let me say a few more words on the network and the impact on price composition. So the prices in the gas market are kind of weird for economists, because it's really kind of you don't have a law of one price. I mean, Ukraine may pay a very different price for Russian gas than Switzerland, for example. And so really the bargaining, the market structure, competition, where exactly you are located matters a lot. So if you are a central node in the network and the gas passes through your country to go to a big market, so like Ukraine, for example, if Russian gas goes through Ukraine to reach Europe, before now that Nord Stream 2 has not been constructed, in this kind of situation before Nord Stream 2, well, Ukraine would have a lot of rents from that, where they can kind of well, they could stop the gas, right? And so then typically what you would have is that Russia would pay either direct fees to Ukraine, what they do, a few billions a year for the gas passage, and then they may subsidize gas by giving it out for a very cheap price. And so basically the gas price may reflect to a very large extent this kind of network monopoly situations. And there was a survey carried out by the International Gas Union, where they asked, well, basically, how much of your price depends really on international world market conditions and what matters on a bilateral monopoly situation. And you see that in very central nodes for the network, where network strength matters a lot, you'll see that graphically, like Middle East, etc., former Soviet Union. Well, the big chunk of the price is really about bargaining and monopoly power linked to the network position. While for places like Africa that are a bit further away from the most central nodes of the network, and where maybe you can, in some cases, you can more easily ship as well the gas in liquefied form. Well, there this goes down, and the bilateral monopoly matters less. Obviously, for liquidified natural gas, then 0% of the price is due to bilateral monopoly. So if in any case gas is shipped by boat, whether you ship it to France or to Italy doesn't matter much actually, and then there is no more this element of bilateral monopoly. But as I was saying, it's much more expensive to liquidify the natural gas. As I was saying, it's much more costly for small, especially for small distances. And but it's more flexible. You can escape monopolies like that. But pipeline represent 80% of the market. It's like the clearly cheapest technology. So it's less expensive to be on the network, but of course then holding a key position starts to matter a lot. So basically, what matters in terms of network? Well, the monopoly power, the number of clients. So holding an important network position is crucial, because it allows you to it allows you to control the network and extract rents in terms of geopolitical rents, but also in terms of just plain money. So basically, the concept we focus on is on betweenness centrality. And so what we do is it measures the extent to which a vertex, like a node, lies on paths between other nodes. And so it's really, it measures how central you are in the network and how many of the different paths have to travel through your node. And this kind of captures both like the bilateral monopoly power around you, but also in general, the number of potential clients you could have that travel through you. And here, if we talk about distance, what we have in mind is the number of nodes and not plain geographical distance. And to illustrate this, take a look at the following pictures. So the formal definition of betweenness centrality is just the total number of shortest path from between different nodes that go through your node. And so here, if you look at the upper left corner, the kind of circle, there every node has the same betweenness centrality. They all, and so you basically have each one has like the same share of nodes going through their node. They have the same network centrality, so it's kind of quite low. But if you look at the low bottom right corner, this kind of star-formed network where you have like here the one with 6, where you have the number of 6 in the middle. Well, that one would kind of connect everybody, right? So that one would be very central, because every node between anybody has to go through this one, through this central node. And so it has a much higher betweenness centrality than all the others. And so that's the concept we use for centrality, which is also compatible with the formal model. Now, importantly, the betweenness centrality of a given country can be modified through conflict. If you basically conquer another node, now you become very central. So if you take the bottom right graph, if you have the node 0 to the right of 6, well, this node now is super not central. But if it went to conquer the central node and merge the two countries, now it would become much more central. So for this node 0 to the right of 6, it would be attractive to start attacking the central node to itself become a central position in this network, for example. And so the punchline really is that the betweenness centrality of a given country, it can be modified through conflict, because if you have a war between two nodes, you conquer the other country. Either you could destroy the other country, which in some situations may be attractive for a country to do, or more often it may be better to merge with the other node, which is more attractive. So either basically you one country incorporates the other country, or what you see more frequently is that they politically control the other country. So it's not like it's if you take Russia and Ukraine, it's not that Russia would kind of necessarily make Ukraine a part of Russia, but it may have some geopolitical influence on Ukraine, to give an example. And so basically, in terms of our model, interstate disputes could indeed arise because you want to merge with the other node, either directly that now the other country becomes part of your country, or more often that you just control to some extent the government of this neighboring country. We start from a formal model where basically oil-related war incentives depend on the endowments and the production geography, and the gas-related incentives depend on the attractiveness of the centrality. And so basically, what we find, one prediction of the model is that, so I'm not going to present the model here, I just sketch it a bit in the interest of time, but what we find is that there will always necessarily exist a high enough price of gas. If it's high enough, you would have incentives in this model for some constellation of countries, you would have incentives to go for attacking the other countries to merge or destroy, because we have this cost of war, which can be thought of as fixed. And if you have this cost of war and you compare the value of this cost of war with respect to what you can gain from war, then if the gas price is high enough, then at least in some constellation, when you can very much increase your betweenness centrality by either merging with the other countries or destroying it, well, then you would have incentives to start a war or interstate dispute against this country. In a nutshell, what this model gives us is the following prediction. We expect that interstate disputes in situations where the gas price is high, and especially for country pairs where at least one of the countries could substantially increase its betweenness centralities when defeating the other. And so, that was the wrong button, sorry. Here we go. Yeah, and so what are the variables that we use? Well, we built three variables. One is the maximizing the betweenness centrality by merging with the other. Second variable is a dummy variable taking the value of 1 if at least one of the two countries in a dyad would maximize their betweenness centrality by destroying the other, or then the third, which is the union of the two, where basically either merging or destroying. And so these are always binary variables, a dummy 0, 1, if in a country pair at least one of the two countries has these incentives to attack the other. So we have, in terms of the big picture descriptive statistics, we have 448 country pairs in Europe, Asia, and Africa. The share of country pairs with direct connections are only 3% in 1970, but going up to over 20% in 2010, which reflects the fact that the network gets bigger. The time period of our study is our sample starts in 94 and ends in 2010. Why? Well, because basically we want to start in 94 because that's kind of the first year after the creation of Russia and the post-USSR countries, and we want them in the sample. It's important to have them in the sample because that's where much of the action is. So that's why we take the pre-sample network of 93 and we start our sample in 94. And why do we stop in 2010? Well, because the military interstate dispute data that we use stops in 2010. And so let me illustrate how our networks look like. So 1970, 80, 90, 93, 2000, 2010. So you see the network kind of gets denser over time. So by using the 93 network, what we do is we have a bit of a risk of attenuation bias to underestimate the results, because we conservatively use a pre-sample network that is less dense than the actual network. And so we would typically, if anything, underestimate the network effect. But what it biases is that the network is exogenous, so it's pre-sample, and it's not like, otherwise, obviously, it endogenously evolves over time. But we'll say more on that. So let me maybe speed up a bit, because I think I don't have that much more time left. So we're already at 37. So in terms of use of, so in terms of descriptive statistics, we have basically in 5% of country per years the narrow definition of big use of force of war, or the broader definition of kind of lower level conflict is in 7% of the country pairs. And then we also have samples where we would exclude some parts of the sample, like Western Europe, Northern Southern Europe, because obviously we care less about some fishing dispute between Norway and Sweden, while we're more interested in the kind of maybe more threatening disputes. In terms of the evolution of the gas price, you see generally it goes up and down a bit. It increases in general. It has more like an increasing trend, but it fluctuates quite a fair bit, and it correlates very much with the oil price. In terms of empirical strategy, so as I was saying, we used the pre-sample network and we interacted with the gas price to address endogeneity concerns. So we have diet fixed effects, we have year fixed effects, so here you have the formal specification. So what you have is on the left-hand side, you have conflict, which is at the country per year level. So we have country I, think Russia, country J, Ukraine, T, year 2000. So that's our variable. That's our unit of observation, conflict. On the left-hand side, these two indicators of militarized interstate disputes. On the right-hand side, we have our variable of interest, which is the interaction of the gas price times a dummy variable of whether in this country pair, at least one of the two countries would have incentives to attack the others, as this could maximize its betweenness centrality. So we have basically the gas price times this variable of whether for a country it's attractive to attack, for a country where it's for one attractive to attack the other. And then we have the fixed effect at the country diet pair. So which means we have a fixed effect for Russia, Ukraine. So if the two countries have for anything like a history of, say, I make it up, like a history of dispute from the 18th century, well, this would be picked up by the country diet, country pair fixed effect. Or if two countries in the sample are both very poor with low opportunity costs of conflict over the whole sample, again, this would be picked up by the country pair fixed effect. Then we have the year fixed effect, which would pick up like global shocks, like 9/11, for example, or some recession, etc. So yeah, so basically that's our structure. We clustered the standard errors at the diet level. So what do we find? Well, I skipped this example in the interest of time and show you the main results. First baseline table is this interaction of having a dangerous diet where one of the countries would have incentives to attack the others, interacted with the gas price. Well, this variable is in, as you see, in most specifications, statistically significant, and the size of the estimated coefficient is somewhere between 1.5 percentage points and 3 percentage points, so around 2-3 percentage points. And what this means is that it's roughly a third of the baseline risk. As you remember, the baseline risk was between 5 and 7 percentage points. So 5 country pair years, 5 out of 100 would on average have conflict. And so yeah, it's quite sizable. It increases conflict by a third, if you like. And then what we do an extension where we now also just, where we now like say, okay, now let's take one step back and let's say that maybe it's not just the network that matters, but it matters actually where the production is, you know. It could be that actually what we're doing, maybe what we're doing is the same thing as we did in our QJ paper 5 years ago, and we're just picking up some kind of asymmetry, and we just label it differently, and we'd say, oh wow, let's have a second paper doing the same thing as the first paper, and obviously we wouldn't want to do that. And so to check that's not the case, what we do is we control now for a symmetry measure of having gas in just one country of the two, so some gas production asymmetry, and then we take some simplified variant of our old variable from the last paper, where we have a dummy of just having one country in the country pair having oil, like a oil production asymmetry measure. And yeah, and the rest is the same fixed effects. And then we get this second table. In this second table, what you see is, well, our main result still holds. We still have the interaction of price with these conquering incentives. This is still positive and significant. Gas production doesn't matter. We don't find an effect, but the asymmetric oil production still continues to matter, as in our paper 5 years ago, where again we find that having just one country having oil in a diet, producing oil in a diet, increases the risk of conflict quite a bit. Similar level of magnitude for the low level of conflict as for our gas effects. Then, in terms of robustness, we disentangle the merging and destroying. We use some other gas price. We exclude top producers that could potentially affect the gas price. And we also have another specification looking at the main effect of the network as well. But I'll skip all of that in the interest of time. And I go straight to the simulation and to the conclusion. So simulations, we do three things. First is, what you see is that the network density increased over time. It went down, it went up from only 51 countries belonging, at least in one constellation, to the risky category, where attacking the country pair partner would be attractive. And this went up to 122 countries in 2010. So before, to put it bluntly, to simplify, in 1970, only 51 countries were potentially at risk of interstate disputes linked to gas, while in 2010 it goes up to 122 countries. And actually, according to our estimates, well, this would kind of more than double the risk of increased tension, just due to that effect of an increased density. And even if you compare between the year 1990 and 2010, so the fact that now we have quite more density would already increase our risk of conflict. So in the paper there will be more details on that. In the paper that's still not fully finished, but we're close to finishing. Simulation 2 is we look at two pipeline projects. One going through they're linked to the Libyan conflict, where basically different fractions in that conflict are linked to different countries benefiting from different pipelines. So what we find is that Egypt would kind of benefit in terms of Betweenness Centrality from the EastMed pipeline project rather from TANAP. While with TANAP, basically the winner would be Turkey in terms of Betweenness Centralities, but it could lead to some tension with Iran, because then this diet now would become kind of one of these dangerous diets once we have this new pipeline. So really, this is just to illustrate that our setting actually allows us to say something on, well, actually, you have pipeline project A, you have pipeline project B. Well, which countries would typically be in favor of project A? and which ones would find it in their interest to be in favor of project B, and if we build A or B, where exactly would you expect future tensions to arise? So it's kind of useful in terms of understanding gas politics and in terms of forecasting potential conflicts. Third simulation, COVID-19. So the gas price, according to one of the indices, was halved in the first 3 months of 2020, huge slash, because obviously there is a bit less of a demand with the industry, etc., being in lockdown. So according to our model, this would predict the reduction of the dispute risk between 1 and 2 percentage points for our country pairs. So that would be like one of the rare positive effects of COVID-19, if you like, on interstate disputes. So let me wrap up. I think I'm close to the end. So what we did is we studied the question of whether and how natural gas can drive interstate conflict. What we found is that it's very attractive to have a central position in the network. Again, a key message is that gas is different from oil. So while for oil, you care about the total production and having control of the reserves, for gas, what you care about is being central in the network, and you may get as many rents from being central in the network as from actually producing the gas. And what we see is that our new results on gas network centrality are actually complementary with respect to our past findings on asymmetry of oil. They both play a role. Together, they're a huge chunk of world energy. Gas one quarter, and oil even one third. So together, they're more than half of world energy is gas and oil. For gas, it's more like the network that matters because most of the trade goes through pipelines. While for oil, it's more like the production that matters. And while there, you send it through tanker, and you less rely on a network. And so our setting allows us to carry out simulations, as we've seen, on particular pipeline constructions, network density, COVID, etc. And so it allows us to do some risk assessment. Okay, yeah. Thanks a lot for your attention.
Thank you very much, Dominic. So we have a question from Mark.
Hi, Dominic. Nice to see you. Thanks for this very interesting
Mark.
presentation.
Yeah, I was pleased to see you in the audience.
Thanks. I have a question about identifying variation. Basically, what you're doing is with all the fixed effects, you're focusing on the shorter term variation in gas prices. If I think about conflict, I would assume that this is much about having expectations about what gas prices are going to do, and I'm not sure if these shorter term fluctuations are exactly what you're aiming for identification. How do you see that?
I guess I think it's a very good point. I think it depends a bit like what model of asset price formation you have in mind. But if it's like a martingale, and if at every point of where you are, you would expect that with 50% likelihood it goes up, and with 50% likelihood it goes down, then maybe the current price could reflect your expectations. It a bit depends on how you form expectations, but it's true that it's a good point, and maybe we could do something about it and see whether in a robustness check we could either have on something on expectations of price, or having prices for longer time periods, if like 5-year periods or something like that. Maybe Massimo and Quentin, you want to add something on that as well? I don't know.
I think it's a good point for robustness, and I agree with our first intuition that you gave about the martingale. That's where we stand so far.
So maybe follow up on that. So I was thinking, but if you think about all these CO2 agreements, and you think that you might want to mitigate climate change, so that this might affect your perspectives of, you know, what you will get for gas, etc. So sort of these agreements or expectations about having these agreements might serve as sort of quasi exogenous variation on your expected future gas prices. That's one intuition that might help on that. The second, and that's very quickly. So, do you know how closely related, or your findings relate to other things that, you know, are very much dependent on your network? Like, for example, streams and the whole literature on how water affects conflict, because it seems to me that this is sort of similarly structured.
Mm-hmm. So again, let me have a go first, maybe, and then if Quentin and Massimo want to chip in. So for the CO2 agreements, that's kind of interesting, and it's something where we're very much like now in Lausanne with this E4S center, where we think about the aviation taxation, how to stop global warming, and so we're very much into that. And it's true that it would be important to take actually the conflict dimension into account. But so what you could do if taxing, you know, I guess the price that matters for the conflict incentives are the prices obtained by the producer, right? It's like it's a producer price. And so if you put a tax, then the tax would typically, in most of our models, if you have a demand and supply curve that have kind of some intermediate elasticity, and you add a tax, then the price touched by the producer would go down, and the price paid by the consumer would go up, and the wedge between the two would be the tax, the tax rectangular. And so there, actually, we could get a double dividend. So we could at the same time save nature and at the same time reduce conflicts with this kind of tax on gas, because the producer price would go down with the CO2 tax, which is something which is maybe something we should stress more. It's an interesting thought.
I think there's more thing about timing. Sorry, I think if you believe that there will be abatement and there will be future policy interventions against extraction, you might want to extract more quickly. So this might increase dramatically your incentives for conflict, because you have to grab them now, because it might, you want to get as much out as you can. So this is the sort of what I know a bit from this oil literature. Thanks, I'll shut up. Thank you so much, sorry.
I doubt that this would be intensified production would be a response because of the overproduction and stock and storage problems that they're having also for oil and stuff. And I would add a political set of consequences of the current, COVID and related crisis, downward shock on gas and oil prices. So it's even more expected that prices could remain low, also because of the political responses, right? So you are now hearing in Europe that carbon tax could be a way to have the taxation revenue side of the fiscal union that is forced by the creation of Eurobonds, and that will be reducing the incentives to use gas when you can. And you have investments in green investments, like in Italy, the main investments that they use, for which they use the European money, is solar energy panels, eco bonuses, etc. So I think that the expectation is lower rents from gas for a few years, and that's maybe related to why Haftar lost his grip, his energy around Tripoli, and now Egypt is only verbally helping Haftar, but reducing the military help, and so on and so forth. So you can see some evidence of that.
Thank you. Gabriele?
Hey, hi. I might have miss some details of the model, so please stop me if anything I say is nonsense, Dominic. It seems to me that in the case of natural gas and the pipelines, you do have an alternative to conflict, which is building. And this alternative is, some alternatives are possible geographically, physically, and some alternatives are impossible. And so that whether an alternative is possible or impossible should drive some of the incentives to go for conflict. And I'm wondering whether you are exploiting this or plan to exploit this.
So you mean the alternatives in terms of building new pipelines?
Yeah, so it seems to me that even some of the examples that we discussed here are about the possibility of building a new pipeline, and that there are wars that are fought and there are diplomacies that are leveraged to avoid building alternatives, right? And I'm saying some dyads can build an alternative because, you know, there is just a sea in the middle, and some dyads just cannot do it. And so we should observe a difference in the intensity of the effect that you have, depending on whether it's possible to build an alternative or not.
Yeah, that's very good. So and it's something that could be kind of quite feasible to do, like heterogeneous effects, right? Depend on geography, like
yes.
So I mean, even on a simpler level than what you said, we could just look at how easy it would be to avoid the network through liquefied natural gas, how close you are to the coast, and these kind of things. So we could quite easily do some heterogeneous effects to see how easy you can kind of evade these network curves, if you like.
Yeah. Also, another answer could be that right now we are focused more on the effect of the possibility of the consequences of merging nodes or to destroy nodes. What you are suggesting is that, for example, another way to see the potential conflicts around the creation of Nord Stream 2 is that Nord Stream 2 is not being created yet, but it's supposed to increase the bargaining power of Russia, reduce Ukraine and stuff. And so somehow there could be like a third sort of bargaining interruption, or like, you know, pipeline interaction type of incentive that could be also coded. Yes.
And there are also military actions that are possible just to prevent somebody from building a new pipeline that is an alternative to the one in which I am central, right?
Yeah, the difficulty on the data, and Dominic can say, of course, much more, is that coding when the pipeline becomes functional was easier. Harder it would be to focus on the time, right? When they started talking about the pipeline and conflict intervening between them, yeah, and the actual, you know, construction. A good example would be the pipeline between Ankara and Erbil, that was considered very, you know, essential to increase the independence of the KRG from Baghdad, and of course that created a lot of conflict in the middle. Yes.
Have you? So you're using conflict, and you mentioned that. I mean, there's this issue with, you know, conflict data is noisy and, you know, not as frequently, especially in Europe post 1993. Have you thought of using something like trade sanctions and things like that, which are more frequent to observe?
I mean, one thing we were thinking of was like international diplomacy. So Quentin has put together some data on UN voting and stuff. So that's something which could be another way of measuring kind of lower level of disputes. And I think the trade sanctions is also something we could look at. That's like a good kind of alternative outcome measure. I guess you know, I mean, our kind of broad conflict measure is actually quite frequent, 7%. I mean, it's more than for most civil wars. You know, most civil wars, it would be like 5%, 3%, something like that. So 7% is not that bad. And it's true that if we take a watered down measure, then we may end up this, you know, measuring disputes between Austria and Switzerland about selling wine or whatever, you know, maybe like very low level disputes that we pick up if we. But it's interesting. It's good. Yeah, we should look at trade sanctions as well. Yeah.
All right. Are there any other questions? No. Well, if not, thank you, Dominic, Massimo, and Quentin for the great presentation. And I found the way of, you know, kind of tag teaming the whole thing with having some of the co-authors answering questions in the chat pretty effective, something to remember for the future. And yeah, as I said, if you haven't done so, please everyone sign up for the